Hey guys, in this video, I'm going to simply explain in an easy to understand way how LLMs work on a deeper level, how the architecture is set up, and how each step of the LLM is structured, right? Imagine, the human body has arm, brain, eyes, teeth, mouth, tongue, chest, bones. I'm going to explain the body of an LLM itself, okay? And I'm going to talk about ChatGPT and the other famous LLM models and how they're structured and how they actually work. So this is a conceptual video, okay? Now, and my name is Shot, also called Stefan. I've been an AI programmer for the past 7 years. So I was part of AI before it got famous and went viral. So I've been doing it since like 7 years ago. I got involved when it was first did statistics and machine learning models were just, becoming relatively known. And then the big boom happened where it started talking, right? When the GPT model had a breakthrough, and then they put it into a nice, easy to use app or website, and that's when it went viral. And now everyone knows about it. So I've been part of this since the very beginning, 7 years. Okay, cool. So this is pretty much the body of a LLM. This is how it's structured and set up. The brain, the part that everyone thinks is like thinking, right, is this part right here. The transformers layer, aka the self-attention layer. This layer is the brain, is the part of the model that's thinking, right? Imagine this as like the brain and everything else is just body parts that these two, this is like the ears. Input text is like the ears. Output text is like your mouth, right? That's like the best way to explain it. And then these two are also part of the brain. This is like all these are part of the brain, but the thinking part of your brain is this, and these other parts are other parts of your brain. Okay, so but let me explain each one one step at a time. Okay, so input text. Input text is essentially the question you're asking it, right? The question, the text you're sending it, the answer you're just saying, the random word you're saying, right? The book you're sending it, but in text form, okay? Keep in mind, LLMs are text models, okay? So if you look at this, if I'm typing, that is the input text. If I go to Claude AI, that is the input text, okay? So keep that in mind. That's input text. Or on your phone. If you're texting on your phone, where my phone go? Don't know where my phone's at. If you text on your phone, that is the input text, okay? So that's why it's like the ears of the model in a way, okay? If your computer had ears, the input text is where that goes to, okay? That's all that is. Cool. Next, we have the tokenizer. The tokenizer is pretty much a translator, okay? So if I want to say pop, you know what? That's not a good example. My bad. Let me say apple. Apple. Okay, let me say run away. Wegel. How do you even say that? Cool. That's pretty much what that part is. This part is a translator. And I want you to imagine that this is English or whatever text you're sending, and this is computer language. Let's say there's an option here. See, we got Hebrew, let's see what the languages are. We got Italian, right? Imagine there was a language option called computer language. This is what the tokenizer does. The tokenizer would take our English, whatever language you write, our text, and convert it into computer language, right? That's what it does. It's a translator essentially, right? Now, then you send, so you get the input text, and then you send that to the tokenizer, which then translates it into computer language, so that the computer can understand what you're trying to say. Okay, more like what the model, so the model can understand what you're trying to say, which is the LLM, right? Now, it goes to the embedding layer, right? And keep in mind, the best way to describe these parts are actually called layers. Like these are all like layers that are happening essentially, or components, some might call them, right? So each square is like a component, or each square is a layer, or some of these are components, some of these are layers. But we're getting a little too technical now, but you get the idea. This is definitely a layer for sure. These two, I might say, are more of components, but that's that. Cool. So next step is embeddings. So an embedding is, and also I'm using this website. It's called, this article, it's called Confidential Mind. They're really good. Please read them. The CEO of that is really cool. Check out their article. All right. I will link the article below so you guys can go read that. But they did a really good example breaking it down. I didn't want to recreate the wheel, all right? They already explained it very clearly with a very nice visual. It's super easy to understand, okay? So cat, dog, kitten. These words, right? This is the tokenizer. The tokenizer does. The tokenizer turns the word cat into this, right? These numbers. This is computer language right here, all right? Now, from there, you send it to the embedding layer, and the embedding, right, So the embedding is a vector, a bunch. Essentially, they work with vectors, okay? And vectors is just this. This computer language gets turned to like another thing called a vector. So it's kind of like, you see how this translator, there's just this word fugiti or whatever, right? There's none of context to this, right? What the vectors do is that it tells me, is this a noun? Is this all lowercase? What languages this is? Does it have a past tense, future tense, or just is it just the word? That's it. Like there's no future past tense of the or current tense of the. The is the same throughout all the tenses, right? So that kind of stuff. Is this word new? Is it old? Things like that. It just adds more information to it. And does this word change if another word's in front of it and behind it, right? So like if I were to put the word child runaway, right? Kind of negative, but if I put AI not AI runaway, but funny runaway, right? The mood of it changes. So it's just word affected by words before and after it. That's what that vector does. It kind of keeps that, it logs the information, right? And expands it more. This is just the word itself. This is like the word and its meaning and its weight, where it comes from, what it is. Like, does it involve animals? Does it involve food? Does it involve science? Does it involve technology? Does it involve genders? Does it involve social studies, right? That's what the vectors do, right? And then they kind of exist in the embeddings or vectors exist in like a 3D space kind of, and like the word bottle might be very close to the word like plastic container, right? In this space, let's say over here, bottle, plastic container they'll be close to each other, but not on the same point in the space. Another way to think about it, and then let me think of like the word hand might be next to the word finger, right? Somewhere else in the space, right? So words will be close to each other that have similar meanings or relationships, right? And that's pretty much how the vector space operates, right? And it's like, in your brain, when I say cat, you think about dog or lion or tiger very quickly just because it's there. But if I say cat, when, we're talking about cats and dogs for an hour, then I'm like, all right, what's the Pythagorean theorem? Your brain has to now like go to the part of your brain that has all the math information, right? So that's pretty much how like the embedding layer works, okay? Then from the embedding layer, once it finds the embedding, then pretty much the embedding layer, it searches for the embedding, searches for the vector that has like, the information it needs to understand what's going on, okay? Like the details of that word, the deep meaning of that word. As a matter of fact, another way to explain it is like if I type in the word here, apple. No, see if I say define apple, right? Like this meaning of what apple is, right? On top of like phrases that include it, on top of the origin, right? The word how it's used over time. This is like what the vector contains. Information like the meaning of the word. Apple is just a word. Cool. I can translate that to any other language. But now, what does the word mean and how is it used? That's what vectors hold. And the embedding layer will go find that vector in the space and bring it to the transformers layer. Right now, this layer is a little interesting to explain. The best way to explain this layer is because this is like what makes these models so special, right? So the idea is that in this layer, if I have the word apple, right? Apple is fine by itself. As a matter of fact, the word run. Let's do run. The word run has multiple meanings, and the meanings are affected by the context. So what this does is, if there's a sentence, it looks at each word and how the word in front of it and behind it affects its meaning. So right, so the vector, now we have all the meanings of run, but now we need to know which meaning of run do we need to care about. That's what this does. The transformers layer figures out which meaning we are using in this sentence for the word the, for the word run, for the word is, for the word bad. And also it figures out which parts of the text do we ignore. There's a period. Does it ignore the period? Is the period important, right? Or is the word is important? Is the word the important? Like, what's the most important word in this sentence? Probably the word run and bad are the most important words in this sentence. Kind of like how when you're, let me just stop right there. Yeah. So just form layer. So the word run, right? Run means multiple different things. So the run is bad. Sounds like you did like a physical activity, but also it could be technology, right? Like the computer running is bad, or the software run was bad, right? So it's trying to figure out what form of bad is this. It will just figure out what's the most common use case of this is, and of course, and this is why it's important to understand how AI works, because the more text you add to this, the more likely it will understand what you're trying to say, because it has more context, it has more meaning in what you're trying to say. This is very broad. It's going to struggle to understand what you're trying to say here, right? It's going to have to guess really well. Now, the run was great today. Most likely this involves running as an activity, right? The run needs to restart the PC. This tells it that, oh, most likely this involves a software update or a software download, right? Like when the apps on your phone update, it's like that kind of run. You run a software update, right? Or also, run. The run resulted in. The run had bad results. Right? This means maybe it was a test. They say they ran a test, or that you run a test, right? This can mean like a scientific test, a lab experiment, right? Or just a basic test, right? But you see how earlier my first sentence was the run is bad, right? Adding the word results clarifies it's probably an experiment, right? But if I remove the word, the run was bad, even you and I are guessing, so the model's going to guess as well, right? This is what the transformer layer does. It figures out, and then the word bad, right? The word bad can actually mean a good thing sometimes. Like, oh man, you're so bad. Maybe let me not use that example, because I'm thinking of like, yeah, let me not use that example. Another example was well, because the word well itself, by itself, the word well is like, well, like, oh, well, or it's like, well, like a wishing well. It's also, yeah, country as well. Well is the word part of a country. We have the water well, right? So what's going on here is that it knows, because well is at the end of the sentence, it knows that it's probably meaning good. But if well was in front of the sentence, it might be noun. So it's also like the order of the word affects what its meaning is. In the transformers layer and the subtension layer figures all of that out. It figures out, because of the position of the word in the sentence and the meanings there, and examples of it being used before, this probably means good. And that's pretty much how it works. It just figures out the meaning of this word in this sentence at that position it figures out the meaning of this word at the position it is in the sentence in this instance. Okay, that's what this famous layer does, and that's what's created the brain of the GPT models. And then we have logits, right? Once the model is done figuring out what you're trying to say, it's going to give you an answer. The answer is going to come out as logits. Logits are pretty much, it looks like the same thing as the embeddings, essentially, right? It's a list of numbers, or it just gives you like each word. How to explain logits? Logits is just a bunch of numbers that need to be converted into probabilities. Okay, probability is like 10% chance that it's this word, 10% chance it's that word, 40% chance it's saying, you're saying this, 40% chance they want me to say this. So it's kind of like when someone talks to you, and each possible thing you could say is the chance of the thing you're saying being the thing that they want to hear, right? That's what pretty much logits are. Logits are the numbers that need to be converted. Like pretty much, it's like the computer language again, like the computer's language, that it spits out these list of numbers that are related to each word, or maybe sentences potentially. So like this number means this word, this number means that word, this number means this sentence, right? That's what the logit does. And then here in the output text, you do a softmax, right? And the best way to explain it is like, logits look like this, list of numbers, and then we do a softmax, which is a mathematical equation, which is, once again, it's a translator. So the best way to think about it is translator. Ooh. Cool. The best way to think about it is, if you're going like this, it's switching this. It's doing Dutch to Apple now. So it's like a reverse translation, okay? So we're doing a reverse translation from logits, softmax to probabilities. So softmax turns the language into probabilities, and a different like mathematical method called argmax, which pretty much finds the highest probability. So this will grab, in that list of probabilities, it grabs the biggest probability, and that probability, whatever word is attached to it or whatever sentence is attached to it, that's the one that gets said, okay? And that's pretty much how this works, you guys. It's very beautiful. It's amazing how this works. And this step by step, that's just how the layers work and the components work, okay? And the thing is now, let me explain this. LLMs do not make sounds. They can't talk. They can't vocally talk. They can only produce text, okay? They also cannot produce images, okay? Their output is not images, it's only text. So 11 Labs right here.
But before we go any further, congratulations. Getting here certainly wasn't easy.
That was not an LLM that spoke. That's an audio model, probably a text-to-speech model, right? Different model, okay? Then you also have like the, matter of fact, I'll show you guys. Apple. Oh, sorry. I need to specify that I want an image. Image of an apple. Or you could just go here and click on create an image. Cool. So right now, this model, it's one of the DALL-E models, okay? The DALL-E model is the model that creates images, right? I think this is DALL-E 3. This is the model that's creating the images. ChatGPT, this is the GPT model. This does not make images. This model makes the images. The DALL-E 3 model, DALL-E 2, the original DALL-E model, that makes the images, all right? All ChatGPT does is send the text that was outputted to the image model, and now that image model creates the image. So the image models are completely different than the LLMs themselves, right? Same with the audio models, right? The TTS models, the STT models. Those are different, okay, than ChatGPT itself or the LLM models. Sonnet 4 is another LLM model. Gemini's model, I think, what is it called? Gemini. Let me see, Gemini. Gemini's model is called cool. And then we have Gemini, right? This is another very famous LLM model, right? And you see the video production. See, it says generate with VO3. VO3 is the video generation model. Gemini does not produce the videos because Gemini is a LLM, okay? Just to clarify all of this. And in the last part I need to make out here, data science, data analysis are all part of the AI architecture or the AI pipeline, because you need to do a data analysis on your data. When you train these things or when you create these things, or even the outputs, you have to analyze the outputs, right? And the methods that data analysts learn help a lot with the AI process of training them or the dealing with the output of the AI model, right? And just, yeah, and then data science also part of that, right? A lot of skilled data scientists learn how to help create these, because data scientists are notorious for using machine learning models, which are the predecessor of LLMs, but they still are important because sometimes these LLMs use machine learning models and they work together to produce outputs, right? So that helps to understand these on a deeper level and how they work, right? And then lastly, statistics. All AI is a giant statistical equation that's going on, right? Math and statistics, that's what LLMs are. LLMs are giant math and statistical equations. So that's why people like me who have a degree in statistics and math naturally end up being AI engineers, because we understand the statistics behind LLMs, right? Markov chain, right? That's a concept in statistics that we learn in college, stuff like that. But you don't have to go to college to learn about statistics. You can learn statistics without going to college. I'm just saying that the field of AI, people kind of assume that you need to have a degree in AI to understand AI. That's not what happened. AI didn't really exist. And AI has been around for almost 40 years, around 40 years, give or take, right? It's been around for such a long time. People just care about it now because it talks. Because when this came out, when the LLMs came out, it shocked the world. And this has existed for a long time. It just didn't talk as well as it did now, okay? So data analysts, AI engineers, machine learning engineers, data scientists, statisticians, mathematicians, we all have very similar skill sets, which led to the creation of LLMs, which are now people call AI, but AI is a very broad term overall, okay? So just keep that in mind. Like as you see, Dolly's an AI, VO3 from Gemini that produces videos, that's an AI, right? 11 Labs, this is an AI. The TTS system, it speaks, but they're not all LLMs, okay? Let me just clarify that. These are all AI models, but they're not all LLMs. Okay, LLMs are its own subcategory of AI itself. Cool? So that's pretty much the best, most simple explanation of what an LLM is, what AI is. And yeah, if you want to learn more about AI, please reach out to me. If you want me to help you integrate AI into your business to make more money or save time, reach out to me. If you have a business idea you want to validate that involves AI, reach out to me. You want me to teach a whole class? I got you. Reach out to me. My email is in the description of the video below. I really appreciate you guys so much. Peace.